Very good afternoon. So in our last class, we started second bit of your fourth module called tidal and wave energy, and we discussed about what is meant by tidal energy and wave energy, and a brief history of tidal energy, and how they are formed tidal energy as well as wave energy, and how they are different, the tidal energy with a wave energy. And the most important thing is type of tides also we discussed. The first thing is diurnal tide, semi-diurnal and mixed tide. So diurnal means only a one high tide and one low tide in a day. It is called diurnal. Semi-diurnal means two high tides and two low tides, and both the levels are nearly same per day. It is called semi-diurnal. And mixed means of course there is a two high and two low tides, but the height is not same. They are varying with heights. And also we discussed what is meant by spring tides and nape tides. So spring tide means a high, okay, higher the level or strongest tide is called spring tides, and nape tide means it's a weakest tide in the a day. It is called nape tide. Okay, so these things we discussed in our previous class, and today we are going to discuss some of the interesting topic in the tidal energy. So in that, first one is a tide gauge. Okay. So this is what the first thing, a tide gauge. So the tide gauge means it's a device. A tide gauge means it's a device to measure maybe pressure. Okay, if you want to measure, it has become a pressure gauge. If you want to measure the velocity, it is a velocity gauge, like this. So here tide and gauge. So tide gauge means it's a device for measuring the change in the sea level, that is what the tide, related to the vertical datum. So it is called a tide gauge. So you just observe in the figure. Okay, so it's a schematic of a tide gauge, a measurement system. So it's a very necessary device to measure the level of the tides, so that based on that level we are going to adjust the mean level of the sea, and we get the high tides as well as ebb tides. So that ebb and high tides, flood tides are they are related to the this sea level measurements. Okay, so nowadays these tide gauge widely used a method for recording recording the continuous rise and fall of sea surface water. You just observe in the figure. So this is what the sea surface water. Okay, so this is a sea surface water, and this is what the a gauge. So in the second figure also you can just observe there is a vertical gauge. Okay, so this it's a widely used method just to recording the a continuous a rise and fall of the sea water, and tend to be located at a part for historical and navigational reason. This is used for historical reason as well as navigational reason. We are using this device. The traditional float a gauge. This is what the floating gauge. You just observe this is a traditional. Traditional means most commonly used a float gauge. It is floating on the sea water. It is always floating on the sea water. Okay, so float gauge records are now largely replaced by a fully automated. So in the earlier days we are using this floated type of gauges, but nowadays this entire thing is replaced by a fully automated radar device. A fully automated radar device that represents an essential database of sea water information. And a tide gauge, which is one of the component of modern water level monitoring station, that is most important, and it is fitted with a sensors. It is always equipped with a sensors that continuously, those sensors are continuously record the height of a surrounding water level. That is most important. It will record the height of the surrounding water level. The data is critical for a many coastal activities. Why we have to measure this data means it's have some reason. We have to measure that water level because it has some activities which includes a safe navigation. First thing is for a safe navigation foreign sound engineering, and habitatal restorations, and fishing, okay, or else the traveling of the boats, or any coastal activities. And these coastal activities are highly depends on this height of the sea level, and that is indicated by this device called a tidal gauge. And before computers were used in the earlier days, before the computers were used to record the water level, okay, that is what high level and low level, especially a tide house, means they made a one special house. That house we can call it as a tide house, okay, and a sheltered a permanent tide gauge, and they are fixed, and they are equipped with that house with a permanent tide gauge. And house inside was the instrumentation, including a well, a float, that is what the earlier what we are using, the well, a float, a clock driven recorder, okay, it's a clock driven recorder, okay. And while attached outside was a tide, okay, so it means something is attached to the tide, some part is attached to the tides. But the modern monitoring system, but nowadays we have to go with a modern monitoring system that was used, and it is advanced acoustic, means with the help of that acoustic means there is a sound which is created by a waves, acoustic sounds, and electronics based on microprocessor technology to collect sea data. That is what the difference between the modern and the earlier days. Earlier days, physically we have to float some device onto the tide, so that will measures the level of the water. But nowadays it is entirely replaced by modern technology that is equipped with a microprocessor, okay, and a device which is measure that sea level with the help of acoustic and electronics based microprocessor. That is what the advanced technology what we are using. The recorder sends the audio signals. That recorder means acoustic means it's a voice based system. That audio signals send to the sensors and down to the half-inch wide sounding tube, and measures a time it taken for a reflected signals and travel back from the water surface. That is most important, and data is collected every 6 minutes. But while the old recorder station used a mechanical timer to tell them when they are taking the recorder, means every time we have to record at what time we are going to take the water level. That is in the earlier days. It's a purely mechanical one. And geostationary and operational environmental and satellites controls the timing on today's station. That is what in the modern station we are entirely depends on that environmental satellites. Geo satellites, they are control this time of the station. So this is what the tidal gauge, and this is one is a previous one, older one, and nowadays this entire thing is replaced with the help of modern technology. Okay, and in earlier days there is a one house which is called as a this house is called as a tide house. It's a permanent one, just to measure the level of the sea water. Okay. Yes. Next, if we move on to the next topic, this is what a gravitational force and a centrifugal force. Okay. So there are the two forces which causes the tides. There are two forces which causes the tides. We already know that at the time, okay, where the sun, the moon and the earth approximately in line, where the sun, moon and the earth is approximately near, okay, it is possible where when the full moon or there is no moon, okay, only two times it will nearly approximately in line or straight line, and the gravitational force of the sun and moon enhance each other, and tide range is then expectationally larger, and the high tides are higher and low tides are very lower than the average. These high tides are called spring tides. Always we can call it as a spring means high tides, On the other hand, nearly the first and third quarter of the moon, the first and the third quarter, you just observe in the slide, when the sun and moon are in the right angle with respect to each other, it causes the nape tide, and this nape tide means it is called as the range is then very small. The range of the tide is very small. The high tides are lower, and this low tides we can call it as a nape tide. Hence the range is not constant, and it varies during 29.5 days lunar month. Means the lunar month nearly 30 days, but here they take an average of 29.5 days. So bring at the maximum to the minimum, to the minimum to the maximum. It will varies. The third quarter moon, it is called nape tide. First and third quarter is called nape tides, and full moon and no moon, it is called as spring tides. Okay, the typical mean range is roughly 1/3 of the spring range, and the actual variation is larger or somewhat it is complicated by a seasonal variation. That is, of course, it depends on the seasonal variations. The variations is periodically, okay, and monthly, and the seasonal range must be occur and taken into account in the design and operational tide power plant. These are all considerations we have to take at the time of designing of the tidal power plant. The tidal range varies from one earth locations to the another. Okay, so in one location we get a maximum, and the another locations we get a minimum, because that is what we discussed in the previous class. That is what diurnal, semi-diurnal and mixed. Okay, and come to the reason for these tides are a gravitational force as well as a centrifugal force. The moon's gravitational pull generates something, it is called a tidal force. Okay, I am repeating, the moon's gravitational pull generates something. The moon's gravitational pull generates something. It is called tidal force. Okay, the tidal force occurs earth and its water to bulge out on the side closest to the moon and a side farthest from the moon. These bulge of the water are called high tides. You just observe, this is what the bulge. Okay, either in the moon, full moon, okay, and there is no moon. So here there is no moon, and here full moon. So on the full moon or on the no moon, so it causes the bulge in the water level. This is what the bulge in the water level. See, so it is near to the moon, there is a bulge, and there is no moon, means farthest to the moon, there is no bulge. So it is bulge. So these bulge causes the higher the water level. It causes the higher the water level, then we can call it as a spring tide. It creates the spring tide, and the reason for spring tide is it's a gravitational force by the moon. A gravitational force by the moon will causes this spring, this bulge in the water. That is what a spring tide, or it is also called as high tide. The centrifugal force on the tide means the centrifugal force is a little known upset of moon, okay, and orbital motion when it is responsible for one of two forces component creates the tide. As the earth and moon, okay, means rotate around its common center. When the earth and moon rotates its common center of the mass, and centrifugal force is produced and is always directed towards from the center of revolution. That is what the centrifugal force. Centrifugal force means if any object rotates on its own axis, okay, it causes the centrifugal force. And because of this centrifugal force, because of rotation, the earth is also rotating on its own axis, as well as moon is also rotating on its own axis. These two will create the centrifugal force. Okay, and this centrifugal force will causes this centrifugal means it will try to send the object towards the away from the earth. Means any object rotating on its own centrifugal force means that the component will rotate it will produce the a object, okay, and that object will rotate means outside that center of rotation, okay. The centrifugal force produced always directed away from, means it is away from the center, always tend to away from, means it is a center, means the object will tends to away, that is what it creates the bulge. So centrifugal and gravitational force are reason for this bulge, okay. Centrifugal force means it is a force created by a earth because of on its own axis rotation, and because of this rotation it will tend to move away the object, okay. So away means the object is moving away, means it will create this force, and this force will try to bulge that water level, it creates the spring tide, okay. Yes, you just observe the first one is called as a high tide, okay, and the second one what we called as a low tide, it is called as a nape tide and spring tide. So this is one is a spring, means the level of the sea water is very high, and these are the nape tides, means it's a weakest tides, these are the some weakest tides and these are the some strongest tides, okay. And these two mainly because of the sun, earth and the moon. So just see, this is a a full moon and no moon, okay. On this time it creates this type of tides, it is called spring tides. On first quarter and the third quarter, so means at the right angle, earth and the moon is right angle to the sun, then it creates the nape tide, means weakest tides. Of course there is a gravitational force and centrifugal force are reason for this nape and spring tide, but they are in line, there is a more gravitational and more centrifugal will causes the strong tides. But in the first quarter and third quarter, because of less gravitational as well as less centrifugal force, it causes the low tides, that is what, weak tides, nape tides. Okay, so this is what the another slide which exhibits the sun, the moon and earth. These are the two spring tides, a reason for spring tides because all are in line, and these are the second picture which explains they are in the right angle, which causes the a very small bulge. So in the water it causes a low tides. Just observe here, the tides bulge is very maximum or more, so that spring tide, and here bulge is very less here, so that because they are in the right angle, so that causes the nape tides. So the latitude of a tidal bulge is determined by a declination angle. We already discussed what is meant by declination angle between the earth axis and the lunar or solar orbital. Okay, so this latitude is always depends on that declination angle, and it will determines the either spring or a nape tide. The spring tide occurs when the earth, moon, they are in the straight line. The spring tides coincides with a new and full moon day, and nape tide occurs when they are in the right angle, and nape tides coincide with the first and quarter of the moon, sun and earth. Okay, so this is what the basic principle of tidal power. Okay, so we already discussed in our previous class. The tides are produced mainly by the gravitational attraction and the centrifugal force with the moon, sun and the water, and it causes water solid on earth and the ocean. Nearly 70% of the tides producing force is due to the moon and 30% is due to the sun, and this will causes the formation of these tides. Okay, and some of the points they are in connect with the tidal principles are: the tides are periodical phenomena, but no two tides in any cycles are alike. Okay, so no, just observe, the tides are periodical phenomena, means periodically there are rise and fall, but no no two tides in any cycle are alike, means they are not same. Means if the one tide is having a exactly 3.545 meter, next tide is not same like 3.45 meter. It may be more than 3.45 meter or less than 3.45 meter, means they are not like. Since the relative position of the sun, moon and the earth, their distance from the earth is continuously changing. That is what the main reason. The distance between the earth, moon and the sun is continuously changing. It is not fixed. If it is a fixed, then we are getting the fixed height of tides. But the distance is varying. It causes the varying in the force, gravitational as well as centrifugal force. That will causes the varying in the heights. That is one reason. And second thing is the main tidal range varies from a place to place. That is also second reason. Means the locations. In just take an example of the tides length in the Mangalore is different from the Karavali. Okay, it is different from the Kerala. It is different from the Tamil Nadu. So like this, it will change with the locations. The shape of the tide cycle depends upon the interaction with the sea, with a coastal line. That is most important. It is depends upon the sea and the coastal line. Where the coastal line it offices reasonably influences the tidal range gets means it may change its tides or it may decrease its tides. Okay, and so these are the some reasons. And next reason is in spite of their complicity, the tides are unable to a mathematical analysis. We can use for this mathematical analysis the resultant of extra time and the water level for high tides as low tides can be forecast with greater accuracy. Means by using some mathematical equations we can predict next high tides or low tides with more accurately. With the previous historic records, with the equations we can easily predict. So this is what the variation in the tides: 0 to 5 days, 10 days, 15 days, 20 days, 25 days, 30 days. So one lunar, so means 0 to 30. It may be 29.5 days, but we are approximately taken 30 days. So with this, it will change its tides: high tide to low tide to high tide, low, high and low. Like this, it will vary. And of course, you can just observe this is a variation in the China and this is variation in the Australia. So place to place, again it will vary. And come to the power, the energy calculation. So we can use some mathematical equations to calculate the energy developed or energy converted by these tides. Okay, so energy available from a barrage is depends upon the volume of the water. Of course, it is directly depends upon the volume of the water. The potential energy contained a volume of water. Okay, so it can given by E, capital E is equal to half A rho G H square. Okay, so H is the vertical tidal range. That is what height of the tidal, high tide, low tide. A is the horizontal area of the barrage basin. Means that is what the basin we are using to generate that power. That basin area, capital A. And density of the water, rho means density of the water, and G is the acceleration due to gravity. That is what force, gravity force. So this energy is directly depends upon area, density, gravity and height. If you want more power, you can increase the area, or you can increase the density of the water, or you can use the gravitational acceleration or height of the tides. But practically we can only change is area, and this density as well as gravity as well as height of the tide, it is purely depends on sun, moon and the earth rotation. So we cannot alter these three parameters. Only the parameter what we can change is area. Either we can increase the area, decrease the area. If you go with a higher area, higher energy. If you go with lower area, lower energy. Only the possible change is area. We cannot alter this density. Okay, so God is already created the density and gravitational force and also the height of the tides. Clear? So this is the equation. So here also one more equation is there, power. So that power is proportional to density, area, volume divided by 2. So here it's again nu. Okay. So one more efficiency, one more term if you want to add, that is what? Efficiency of the turbine. So with this equation we can add one more term, that is what? Nu or mu. So that is what the efficiency of the turbine. Okay, the maximum efficiency of the turbine is 70%. We cannot go with higher because it's a mechanical component, and mechanical components having more losses, more friction, so that efficiency always less than 70%. Clear? So the power generation depends on efficiency of the turbine, the power generated, density, area, and velocity of the flow. So here if you want more power, you have to go with a more turbine efficiency. We can go with a more density, more area, more volume. Okay. So of course the efficiency is restrict only 70%. We cannot go with higher than 70% because we cannot completely eliminate the friction or mechanical contact, so that there is an efficiency is less. And the power generated heat, of course we can have some these components, and density of water we cannot change. So that sea water having 1025 kg per meter cube, that is what the density. And of course different sea having a different densities, but they are nearly same. And swept area, of course we can increase or decrease the swept area. And velocity of the flow also we cannot vary. It is completely depends upon the high tide, low tide, based on the gravitational or centrifugal forces. Okay. So these are some equations what we are using to calculate the power generation from tidal energy. Yes, next important thing is components of the tidal power plant. So come to the tidal power plant, it has so many components like windmill, like solar. So solar having an panels, okay, solar cells having a glass tube cover, collectors, okay. So N type, P type. So like that, the tidal power plant also having some of the components. Without these mechanical components, we cannot convert tidal energy into a mechanical or electrical energy. So we need some components, and those necessary components they must and they will convert this one form of energy into another form of energy. Okay, and there are main components of this tidal power plant are a powerhouse, a dam, barrage, and sliceway. These are the three important components. And apart from these components, the turbine, the electric generator, and other equipments, and function of dam is from the barrier between the sea and the basin. We need a basin, okay, and sliceway used to either fill the basin during the high tide or empty basin during the low tides. Okay, so these are the three important components, and these three important components are powerhouse, which includes these three components, and dam includes these components, and sliceway includes these components. Okay, so first the three important components are powerhouse, dam or barrage, and sliceway. The turbine are necessary components in the powerhouse, turbine and the generators, and sliceway it used to fill or empty the basin, and generally they convenient to have the powerhouse as well as a sliceway nearly aligned with the dam. They are aligned with the dam, they are preferred. The design cycle may also provides a pumping between the basin and the sea either directions, and it reversible pump turbines are provided. That is most important. A reversible turbines also they are using, and means in the both directions they should operate. The turbines what they are using, it is operate in the both directions, in one direction and another direction if the water flow is continuously changing. So based on that it will continuously rotates. Yes, this is a figure which shows the tidal power plant, and here the tidal basin, this is a tidal basin, and this is what the sea, and here this is what a slice gate, it is a third component, sliceway, and here there is a road and tidal barrage and the turbine tunnel. Okay, and this is water is flowing in this direction as well as from basin to outside. Water is flowing in both the directions. You just observe, this is also another plant layout which explains how the tidal power plant working. And come to the first thing, that is what powerhouse. It includes the dam or a barrage. Okay, the first component, if you go with one by one, the dam or barrage. The dam and the barrage are they are the two common words. They are more likely same. The barrage has been suggested as a more accurate term in the tidal power plant. Okay, and it has only withstand a fraction of the structure height, and stability problems are more modest. However, the literature shows that it makes the distinction even though the head are small with the tidal offcuts. This a tidal power barrage have resist a waves whose shock can be source and where pressure change a side continuously. And barrage needs to provide a channel. These barrage or a dam needs a channel for the turbine in which a pre-stressed or reinforced concrete, it is completely made by a pre-stressed or reinforced concrete. To build these channels, it's a temporary a small dam is necessary, but it is now possible to build them on an land and float them to a site and sink when they are into the place. And the next part is gate and the locks. This is what the thing. Okay, and the tidal power a basin have to filled and empty, means it should be filled and empty. That's why we are using a slice way. It is called as a gate. Okay, and it is called as a lock. And gates are opened regularly and frequently, but the head is very high and in a high, and the side is they are occur, which is not the case with conventional river project. We are not using in like a conventional river project, because in the conventional river project it is the water flow in the one direction, but in the ocean and sea the water flow in the both the directions. And the next is powerhouse, and this powerhouse is available in the larger size because it equipped with a turbine and the generators, where we can convert one form of energy into another form. This is called as a turbine. Okay, and this turbine is in turn connect with the generators. This turbine in turn connect with the generators, where it converts mechanical to electric energy. And these turbines are operating where the water flow in the one direction as well as in the another direction. So that's why powerhouse is a very important component. So these are the necessary components. With these components, we can effectively operate a tidal power plant, and we can easily convert a tidal energy into useful form of energy. Okay, so this powerhouse, what I told, it should be a large size, and with a small means if a small head available, hence the powerhouse is also in a large structure. And there are three types of powerhouse we are using: bulb type, rim type, and tubular type. And in the system with a bulb turbine, the water flows around the turbine and make access for maintenance difficult, as water must be prevented from floating past the turbine. But in the rim type, the rim turbines reduces these problems, as the generator is mounted in the barrage. The right angle to the turbine blades, unfortunately it is difficult to regulate the performance. We cannot predict, or we cannot constant the performance. The performance is continuously fluctuating, and it is unsuitable for the pumping purpose. But if you go with the tubular type, the tubular turbine have been proposed for some of the UK, means United Kingdom projects. In this configuration, the blades are connected to a long shaft and oriented at the right angle, so that generator are sitting on the top of the barrage and easy to maintain and also easy to pumping. Okay. Yes, you just observe. It's a bulb type turbine, rim type turbine, and a tubular type of turbine. So it's all single turbines, single basin turbine. Okay. So it's a bulb type, it's a rim type, and it's a tubular type. So these are the turbines. They are placed, and they are main reason to generate, and it is connected with the generators just to convert one form to another form. Yes, in the next class we will discuss the classification of tidal power plant. Yes, this is what the tidal power. Yes, this is what the bulge, okay, forms the spring and nape tides. These are some coastal lines where you get the tidal power plants. It's a low tide and high tides. High tide and low tide in daily it occurs. Yes, this is need a 5 meter. And tidal technology means, yes, this is how they are operating the turbines. Yes, tidal barrage, tidal barrages. Okay, it's a basin. It's from the, it is a dam, turbine, generator. It's a basin. Yes, it's both directions. It will flow the water and generates energy. Tidal fences, it's a vertical one. And tidal turbines, it's another type. These are the three different types of turbines where we are using to generate the tidal energy. So because of tides, it continuously rotates, and there is a generator which converts electric energy, and because of the tides. Density is more, so that more energy when compared to the wind. Easy to install. Yes, there is no combustion, there is no pollution, so these are the some advantages. Yes, these are the power plants, they are installed, and predictable energy sources, and continuously we can generate the energy and we can supply for utilized purpose. It's a reliable energy source. When compared to the other sources, this tidal power is a very low form of energy. Means if you compare with a conventional energy source, this the power generation is very low. If you want to increase, I just told that equation E is equal to half that A means area, density, height, and gravitational force. These are the some parameters which affects the energy, tidal energy. Okay, so with this I'm going to wind up.